So what we are doing is we're going to break this up. Let f be a continuous function such that from 0 to 17, the whole thing equals 8. Well, if 17 to 20 equals -3 and 13 to 20 equals 7, what is the value of 0 to 13? So what we need to do, excuse me, is go 0 to 17, go 17 to 20, and then subtract 13 to 20. Because if we do that, really this will give us from 0 to 20, and then if we subtract 13 to 20 off of it, what will be left is 0 to 13. So essentially that's the game you want to play, only we know what the integration equals, so we're just going to use these numbers. So we're going to do 8 plus -3. So 8 plus -3 is going to be 5. We're going to subtract 7, so that should end up being -2. I don't know if you were expecting anything more exciting, but nope, sorry. That's it. 38. Next. Let f be defined. Ooh, I didn't open anything. Oh, well, whatever. Let f be defined above where k is a positive constant. For what value of k, if any, is f continuous? Okay, so there's going to be two types of questions. They're going to talk about continuous, and they're going to talk about differentiable. Okay? If it's differentiable, that means we need to take the derivative of the top and the derivative of the bottom, set them equal to each other, and solve them. If they're just talking about continuity, we just want to get this one equal to this one. Because if they're equal to each other, then wherever this graph finishes, this graph can pick it back up and continue to go. And that's where the continuity comes into play. So don't ever worry about what they look like. All you're focused on is trying to solve this whole problem for k. So if we do that, we are going to put a 1 underneath here and then cross multiply. And then this is going to get a little sticky. Okay. All right, equals 16. And if we continue on this path, we can, do all this stuff, right? But what value are we specifically looking at? We're looking at 3. So what we are going to do is we're going to plug our 3 in here. So if we do that, we can focus our energy, because remember, it's continuous for anything until we hit 3. And what we need to do is make sure that when we hit 3, that this one picks up right where the other one left off. Everywhere else, we don't care. Like, it's going to be continuous. It's not undefined. Like, we're focused solely on where they stop at 3. So, if we do this, we get k to the 5th minus 3k to the 3rd plus 3k squared minus 9 equals 16. Subtract 16 from both sides, and we get k to the 5th minus 3k cubed plus 3k squared minus 25 equals 0. So let f be defined the function above where k is a positive constant. For what value of k, if any, is f continuous? Well, we're going to have a couple solutions, because with k being to the 5th power, it means we should have 4 humps. 1, 2, 3, 4. Oops, too many. And we're going to start low, finish high, because this is a positive constant out front. So we have 1, 2, 3, 4. And because it's a 5th power, you always go down by 1. So we have some potentials. What I would do, see this bad puppy tells us we need to go to Desmos. And I'm just going to throw this over here. Oh, not that one. Sorry. There we go. Oh, it's still up here. Okay, so let's do that. K up to the 5th power minus 3K up to the 3rd plus 3K up to the 2nd minus 25. Enter. Oh, I bet it won't work because it needs X's. What about that? Okay. So, we can zoom in and out. We can look at whatever we want. You're going to see right here, there's a couple humps and all that good wavy stuff that we're looking for. But our only 0 is at this value. Oh, so let's click on it. 2.0 day 1, letter A. The solution to this equation as k is greater than 0, k equals 2.08. With this value of k, the limit as x equals 3, f of x exists and is equal to f of 3. Therefore, f is continuous at x equals 3. So showing that the limit as we approach the left-hand side is equal to the limit as we approach the right-hand side, showing that they are equal to each other. I think I need to get in the habit of this first step that I'm not doing. So let's just take a quick chat about that. What I think I need to get better at that I'm not doing proper job of is saying the limit as x approaches 3 from the right of f of x needs to equal the limit as x approaches 3 from the left of the function. And if I start doing this, then that sets up why I plug 3 into my function. And we can cross multiply and all that good stuff. So this is going to be good, good practice for me to start doing this to get to where we need to go. I mean, where we got is where we needed to, but I think this, if this was an open response, I would probably lose a point myself because I'm not putting this, which I need to get in the habit of. And just addressing the limit factor of the problem. Okay. The table above gives values of a continuous function f at selected values x. Based on the information on the table, which of the following statements must be true? F has at most 1 0. Okay, well, let's talk about this. So at -5, we are at -9. At 0, we are at 1. And at 2, we are at 5. Our graph, think about it, can do anything it humanly possibly wants. So f has at most 1 0. Well, I don't know if it's at most, but at least 1 0. F has a relative maximum at x equals 2. I don't know about that either. Think about this. Can we go up and then come back down to get here? Remember, which of the following... Oh, here's a good staple too. I always try, especially with these types of questions, underline what I'm looking for. I need it to be true. I need it to be true. It's either going to tell you to be true or false. You want to make a point of telling yourself true things. So, is this true? No, I don't think so. Is this? I don't think so. There exists a value C. Oh. All right, now hopefully this should be ringing a bell. IVT. Remember, if it's continuous and we start at one value and go through the other value, and we know this is down at -9 and this goes up to 5, we know we have to go through all of these values, okay? We have to. Now, could we do this in a straight line? Sure, we could do that in a straight line. Does it have to be a straight line? No. But there exists a value c from -5 to 2 where f of c equals 4. Well, if we start at -9 and we go through 5, it at some point has to get through 4, doesn't it? I don't know. I think we found a winner, but there exists a value f prime of c equals 2. So 5 minus -9, -5 minus 2. That would be a positive 14 over, I see where it is, -2. So our slope, remember, this bad boy is bringing in, I should use a different color, sorry, MVT, the mean value theorem, which states that at some point, from start to finish, find the slope, and at some point, we will get that value. Is that right? What am I? -5, -9. y2. Oh, I did that wrong. I was like, wait a minute. Why? That's not a negative slope at all. So y2 minus y1, x2 minus x1. And that becomes a positive 2. The table above gives values of a continuous function, f, at a selected extending information on the table. Which of the following statements must be true? There exists a value c between -5 and 2 such that that c value is going to hit 4. I totally agree with that. I know between -5, my c values, my x values, between -5 and 2, you are going to go through 4. There's got to be some time where you go through 4. And then when we look at between -5 and 2 again, at some point the instantaneous slope will have to match the average slope. I actually think it's both of them. I don't know. The computer's gonna have to prove me wrong, but I actually believe both of these are right. There's probably something I'm forgetting about this, but I don't know. I don't know. And of course, it's not going to talk about that. I'm curious though. I'm going to do a quick. I won't take too long, but I actually want to Google mean value theorem. Mean value theorem. Don't need calculator. Just the mean value theorem. No thanks. Oh, here we go. Can we get an article? Can I get an article? Oh, it's just going to hate on me because I'm not logged in. Oh my god, of course it is. F is continuous on the closed interval. Was it an open interval? I mean, it's closed. f is differentiable. Oh, there it is. There it is. Huh. And that's the rub. And that's going to be the difference. And it's going to be something just that slight that's going to tell us the difference between which one we need to use and which one doesn't work. We need to know that f is differentiable on the open interval. Okay? And the only thing that it says is that it's continuous. That's it. So, there is minor glitch in this problem. All right. Hopefully that makes sense to everyone. Like, the slope did work, and it is 2. The problem is it didn't tell us that it was differentiable. And remember, just because it's continuous, our prime, come on, what are you doing? Our prime example, that's continuous, but that is not differentiable, because what is the instantaneous slope at that point? Is it the negative slope or is it the positive slope? We don't know. So we can't do that. So when it comes to a point, a cusp, what were the other ones? I forget. I guess those are the two big ones that are continuous, but not differentiable. Because is it that is our instantaneous slope at the bottom, or is it that one that's our instantaneous slope at the bottom? So that's the tricky part. So, continuous, but it didn't say anything about differentiability. Tricky, tricky. So, the function f is an antiderivative of the function g. Defined by that. Which of the following is an x-coordinate for the local maximum of the graph f of x? Oh, so they're telling us that if I were to integrate g of x, I would get to f of x. F is the antiderivative of the function g. So you have to think about g is f prime, f prime of x. So when it says which of the following x-coordinates of the location of a local maximum for the graph y equals f of x, we already know what the derivative is. We have it. This is our derivative. This is going to tell us max, min, increasing and decreasing. So we already have that. Let's set them equal to each other. Then we can square both sides and get 9 equals x squared plus x plus 4 cosine x. Once again, let's bring in that bad boy into play. Definitely use that bad boy. If you can, make your life simple. X squared plus x plus 4 cosine x minus 9 equals minus 9. Okay, so I have two values. One is at negative 3 point and one is at positive 3 point. All right, our question says, which of the following is an x-coordinate of the local max? Okay, so here we go. This is our graph, and this is, if this is our graph, let's draw that out. So when we look at this graph, we have a parabola that comes here and goes there. Okay, if that's the case, remember, this is a plus to a minus, this is a minus to a plus. So what we're doing is we're increasing, then we start decreasing. That creates a max. Then we decrease and then and start increasing. That becomes a min. So where does our maximum happen? It's at this one at the -3 decimal. 3.9, which if we double check, it was -3.961, which was the answer on the test. What? Local maximum f of x, where f prime equals g, changes from positive to negative, and then crosses the x-axis. What? I don't know about that. I don't see that here. I don't see that at all. Well, let's see. Wow. This goes from decreasing to increasing. It goes from increasing to decreasing. That's a tasty one. A local maximum for the graph occurs at the value of f prime, which equals g, changes from positive to negative. The graph, g of x, crosses the x-axis from positive to negative at x equals... Okay, so let's just, for giggles, put 3 minus Okay, so we did that. I'm curious though on why we get a different solution. That's what's interesting to me. Because this is how you would do it non-calculator portion. So why all of a sudden, maybe just because you need to solve that? I don't know. That's a curious though. But you can see, like, we did positive to negative, right? See how this goes negative to positive? That's a minimum value. And positive to negative, that's a maximum value. So I do understand using the original formula, not the one we manipulated, but the original formula, and seeing that definitely gives you that answer. I'm just wondering why. Oh, here we go. But since y equals gx goes from negative to positive, this would be a local maximum, not a local max. Yeah, this is a value of x where f prime of x equals g of x equals 0. But since the graph of y equals g of x goes from negative to positive at this point, it will be a local minimum for the graph. Yeah, but they don't tell you why. That's interesting. Well, I mean, it's true. We just discovered that. What was the other question? Oh, yeah, because this is curious then. Incorrect. The mean value theorem cannot be used to claim their existence in the open interval f because there is no assumption that f is differentiable. See? Yeah. See, I know some stuff once in a while. But yeah, see, it doesn't say anything about differentiability, so that's why I can't use it. This one's crazy, though. Like, you should get the same answer either way. I don't know. Don't manipulate, I guess. Oh, oops, sorry. Oh. The graph of y equals f of x over the interval from 0 to 5 is shown above. Which of the following graph could be for the derivative? So we have... Excuse me. Okay. We have an increasing function, so that means the derivative has to be positive. Then we start decreasing till we get to 3. At 3, there is no instantaneous slope. It's 0. That's why it crosses here at 0. And then it starts going positive, which is why, and you can see all these constant, the negative, constant, but this is a negative constant, which means the slope would actually be going this way. And then constant, and then it starts at 0? No, there's, oh, I see what they're trying to do. They're saying that this is 0 slope, and it's not. It's just undefined. It's just a disconnect. And then we start going negative. And it can be it because they're saying this is 0 right here. And that's not a 0 slope. There's a slope on this side of a negative. Okay. Sorry, I gave that one away. At time t, from 0 to 2, the velocity of a particle moving along the x-axis is given. So there's a velocity at time equals b. There will be a time at which a particle changes directions, moving left to moving right. What is the total distance traveled by the particle in the time interval from 0 to b? Ooh, wow. Left to moving right. What is the total distance? So first thing that it's saying, I guess we can look at this. So we are going to integrate v of t dt from 0 to 2. This should tell us the particle moving from left, let b be the time. So we go from 0 to b, right? At time t, from 0 to 2, the velocity of particle moving along the x-axis is given by this. Okay, so let's do this. Let's go to the graph. Like, we have a graphing calculator. It's telling us to use the calculator. So let's try it and see what happens. We get t, the sine, oh, I guess I better use x, sorry. X, the sine of x cubed. Okay. Let T of B be the time at which the particle changes directions from moving left to moving right. So 0 to 2. So from 0 to 1.5, it's moving to the right. Then from 1.5 to 1.85, it's moving to the left. What is the total difference traveled from 0 to TB? So we just need to integrate this function from 0 to 1.845. X. Okay. All right, Schmidt, I don't get what you did. Okay, so here is what was happening. So when we go from 0 to whatever this value is, these are all positive. This means we are moving to the right. Positive and negative is just direction. So negative, this is to the left. And then we go back to positive, that is to the right again. So it said, in our problem, it said from 0 to 2, the velocity of the particle is moving this. So we just know that this is the shape from 0 to 2. So our window really, I guess I don't want to do that, is from 0 to 2. So our only focus is from 0 to 2. Okay? It should be x equals 0 to 2. Yeah, okay. Yeah, I don't know how to do decimals. Comma x, comma 0, comma 2. Yeah, no. Okay. I don't know. Anyways, we're only looking from 0 to 2. So it wanted to know, let t equal b at the time at which the particle changes directions from moving left to moving right. So from negative to positive. So from negative to positive, which was this value right here. That value right there, okay? And then it's asking what is the total distance. So if we have velocity, velocity is the first derivative, where total distance, that's position, that's the integral. So I knew I wanted to integrate my function from the beginning up until it changes from left to right, which would be 1.845. And I don't know, did we even check this answer? I might even be wrong. And of course I'm wrong. The graph, so what did I do here? So 0 to b equals 0 to 1.85. It was correctly determined that the particle changes directions at that. This value might be stored in a calculator and used for the limit of integration in order to ensure accuracy. Oh, we had to do the absolute value of it. And that's why, because we have to do the absolute value of the velocity. So this is kind of like a speed thing. So we needed to do ABS. So one of the ways we could actually break this up, if we wanted to get that, is we're going to paste it plus paste it. Okay. We are going to go from this value, whatever it is. Okay. So that's going to be here, 1.4 5. Okay. And if we change it from adding to subtracting, that will change our negative and flip it back over. And then this one needs to go to 1.465. Remember, I told you way back when, I will repeat it myself. I'm a teacher, but I still make mistakes as well. Mistakes and wrong answers are opportunities for growth and learning. It happens. We're what we think is a good idea. But the problem is they're looking for, if the particle changes directions, what is the total distance? They want the total distance. So even what they're doing is they took this distance and subtracted this distance, and they added those together for kind of like the displacement. But that's not, if I walk a mile to the right and then I walk 2 miles to the left, did I only walk 1 mile? No, you walk 3 miles, but it's only calculating 1 mile because those directions are opposite. So what they want is, let's find the positive integral from 0 to 1.465. That's already positive. But what we need to do is flip this one over in order to get this value as well. So that's why we subtract it, to flip it over the x-axis. And then that's where we get the 1.011. And if you look, and you could actually put this integral into your calculator. I just don't know how to do absolute value for, I don't know. Maybe I can use, there's a key. Where's the one? Here we go. Let's see if that works. Oop, wrong one. Yeah, see, if you do the absolute value of what's inside of that, it's kind of like a speed problem. If I want the speed, that's what I'm going for. I'm doing the absolute value of it. Tricky, tricky. And you can see you get the same value either way. A little rounding error, but these numbers are being rounded as well, which is where the rounding error is coming from. Let me be clear on that. All right, 43. Let the f be defined 4, 3, 2, 1. How many values on the over is the instantaneous rate of change equal to the average rate of change? Ooh, good question. So once again, mean value theorem. We're starting at the end, going to the beginning, or vice versa. Starting at the beginning, going to the end. From 0 to 1.565. We're going to calculate that slope. And what we're going to do is we're going to look for that slope that many times. Let's slide this over here for just a second so that I can type in this function correctly. And we're going to go x equals 0.25 x up to the 4th minus 2/3 x up to the 3rd power. To the 3rd power, 0.5x squared minus 0.5x. Okay, so 0.25 x to the 4th minus 2/3 x cubed plus 1/2 x squared minus 1/2 x, and we're looking from 0 to 1.5 something. There you go, 1.565. And what are we looking for? We're looking for where this average rate of change is equal to the instantaneous rate of change. So if we do that, what we're going to do we're going to do that, and that's going to give us a value. .614 divided by 1.565, and that's going to give us a slope of 0.392. Now what we're going to do is take the derivative of this, set it equal to that, and see how many x values come out in the wash. All right, so obviously they pick these numbers for a reason: the quarter, the 2/3, the 1/2, and the 1/2. And what's going to happen is I'm going to do 4 times 1/4, and that's going to cancel, and I'm going to get x cubed minus 2x squared plus x minus 1/2 equals, and once again, if we have a calculator, do yourself a favor. Is this a calculator question? It very much so is. So we have x cubed minus 2x squared plus x minus 0.5. Enter. We have that. And then we have 0.392. We have what let's do y equals. We have that. Because that was our solution, right, for the slope, which is, remember, dy over dx, so that would be f prime. So that's why we did y equals this, because if this is our function, it's really f prime equals this function. So our y values are f prime values. And there we go. 1.72 is where these two intersect. Oh, we don't even need the value. What it's asking us is for how many x values. Well, how many of them are there? Between 0 and 1.5? None. Three. What? Oh my god. Negative. Oh, criminy. Negative. Oh, look at that beautiful thing. 1, 2, 3. Oh, beautiful. And of course, I put positive. You want to know why? Because I was an idiot. When I typed it in my calculator, I just did the decimal and was like, I know it's going to be a negative answer. Negative will get you every time. So, 1, 2, 3. There they are. And that's exactly what we did. Show, and look, the graph of f prime produced using a calculator intersects with the horizontal line y equals this 3 times. Like, they're literally telling you to do exactly what I did. Graph it, graph the slope, which is a y value, that's your dy dx, and see where they intersect. And then this one would have been 0 if it was positive, not negative. That's where your boy screwed up. Okay. Hopefully I can go 2 problems without doing any more mistakes. Well, we can do that one. Oh yeah, we actually, this one we skipped, but this was a crazy problem. Let g be twice differentiable function where g prime is greater than 0 and g double prime is greater than 0 for all real numbers. If we know g of 3 equals 12 and g of 5 equals 18. So this is where we did actually have to g of 5 equals 18. What did we do? We did 18 minus 12. and we did 5 take away 3. Okay? And when we did that, we got 6 over 2, which is 3. So when we do g of 5 minus g of 3 over 5 take away 3, that's just our slope, right? So which of 20, 21, and 22 are possible values? Well, remember, this is increasing and this is concave up. Up. So we're doing that. The bowl is opening up. So we need this to be increasing and concave up. And if we use for g of 6, 20, 20 take away 18, 6 take away 5, that's 2 over 1, not greater than 3. If we do 21, 18, 6 over 5, we get 3 over 1. That's okay. If we do 22 minus 18, and then 6 minus 5, we get 4 over 1. So this one checks off as well. So when asking what are our possible values for this one, it works. And then when we test out this with 12, 20 take away 12. Well, actually, we don't even need to do this one because it didn't work for this one. So if it doesn't work for this one, it can't work. So we don't even need to do that one. And that's where this is going to come into play. 6 take away 3. So that's 2. And what is that? 6, 7. That's interesting. That's 9. And that's a 4.5. Okay, so when we did this with 5 and 3, and 5 and 3, g of 5 and g of 3, we got our final answer to be 3. So if we want it greater than 0, if we want it increasing and concave up, it cannot equal it. So this is where this one does not check off. Because if it's equal, that doesn't mean it's increasing. It means it flattens out, like the derivative is 0. So we definitely can't have the same slopes here and here. So that's telling us that this one doesn't work either. So you have to test both of the points, not just one of them. Now, when we tested the first one, that gave us, the first one didn't work because 2 is obviously less than 3, and it has to be increasing and concave up. So it needs to continue to get bigger and bigger and bigger. So 3, oh, that one doesn't work anyways, because 3, these are equal to each other. So that would tell you that one doesn't work too. So you could have done it both ways. And then both of these are greater than 3. So then that means it's 22 only. That's why. Yeah, this was a crazy trick question. I told my students to skip it. And then we started talking about it in class. And we came up with this. One of my students came up with this theory. Great. Smart. All right, last problem. So the table above gives values of the differentiable function f and its derivative at the selected values of x. If g is the inverse of f, which of the following is the equation of the line tangent to the graph G at point? So, which of the following is an equation of the graph of the line tangent to the graph G at point where x equals 2? So we do, no, we need, so this is, for these types of problems, this is kind of your dead ringer. And what my brain was going to is, am I going to use this one? Or am I going to use this one? And sometimes it doesn't matter, but sometimes it does. And if you think about your derivatives and what you're looking for, I need to get a line tangent to the graph of G, which means the line of tangent is the y minus y1 equals dy over dx, and then x minus x1, which dy over dx has got to be our g prime of x. So if that's the case, then what I really want is this one. Because then g prime of x will equal 1 over f prime at g of x, which doesn't help me because I don't know the values of g to plug back into this. But if I do this one, g prime of f of x times f prime of x equals 1. I think what I need, we're gonna test this one out. I really think this is, but we'll run the road and see what happens. So we are looking for g prime when x equals 2. So g prime at f of 2 is 1. So we're looking at g prime at 1. Prime at 2. Oh, we already know that. That's 4. Okay, so what did I do? How did I get this? Well, what I did is I did f of 2. F of 2, so f of x when x equals 2 is 1. That's where this came into play. It equals 1 over f prime at 2. So now I'm looking at 2 again, and what is f prime? That's going to be 4. So unfortunately, I don't think this is where we're going. So let's try it in this one. So g prime the table above gives the values of differentiable function f. If its derivative at a selected point on x, if g is the inverse function of f, which of the following is the equation? Okay, let's keep this here. This may be beneficial to us later. Let's just keep it here for now. Okay, let's go through this one. G prime at 2 equals 1 over f prime at g of 2. And right now we don't know anything about g. All we know are f's. So if we do y minus y1, well, I don't know what y1 is yet. We need dy over dx and then x minus 2. Okay, now if they're inverse functions, that would mean if I wanted f of 2, if I want g of 2, that means f of x has to equal 2. So if I want g of 2, that means f of x has to equal 2. And remember, if I want this to equal x, then what is going to get me 2? 3. So then g of 2, this is going to be 3, which will be plus 3 on both sides. So then I get y equals dy over dx to x minus 2 plus 3. Because remember the inverse relationship, whatever I plug into here, inside of my function, I should get x out. So g of 2 is going to be equal to the x value of what f of 2 actually is. That's how that inverse relationship works. Now, now we know g of 2. G of 2, 1 over f prime. G of 2 is, what do we say g of 2 is? G of 2 is 3. F prime at 3 is 5, which means this is going to be 1 over 5. Wow, this was a wild question. 1 over 5, nope, 1 over 5 minus 2 plus 3. Ooh, cross your fingers, see what happens. Okay. All right, so what, yeah, I did it, great. But what's really the sticking point? The sticking point is this. If we have g of f of x, that's got to be x. If we have f of g of x, that has to also be x. So what we want to know is if x is 2 for g, what gives us that inside here? And we're looking for f of 2. And when x equals 2, no, what am I doing? Okay, hold on. Now I'm screwing this up myself. So I want g, and I want this to be a 2. And I need to know the x value that gives me that this is a 2. So what I need is f of x to be equal to that 2, because that's what I'm looking for. So when I do that, what I'm really looking for is f of x equals 2. What is this value that's going to make it work? And that means x equals 3 in order for that to work. So this is my 3. And that's where that connection comes from. But that is tricky, very tricky. Well, anyways, that's what we're gonna roll with. So I'm gonna stop. I'm gonna post it on YouTube so that my students can catch it whenever they need to. And what do we do? 37 through 45. I don't even remember now. So 37 through 45. Okay, so let's do this. 37 through 45. Columns. Boom. Let's take a snippet of it. Oops. All right, well, without further ado, make sure, don't be afraid to join the Discord. You can always pop in, ask questions in this chat, ask questions in the questions chat. You're welcome to also join Twitch. And let me, can I disconnect? How did I do that? Docs. I don't know how to disconnect chat, but you can see over here that the chat pops up right here too. And oh my gosh. So I can see when you post questions in my stream as well. They would pop up right here. So don't be afraid to ask questions, even with my mistakes. Hope you could have caught them before I made them. So join Discord. Math Dragon Tutoring. There's links in everything. Just look around during either my TikTok, YouTube should have one. Yeah, just check it out. All right. Other than that, have a blessed day.